to memorize these formulas, but you will have to have them handy. So when you go down, when you sit down by Alex, make sure you do have all these formulas available. All right, so let's just get going here in section 7.4 with compound interest. Now, I must warn you that there are cable trucks up and down my road. My cable was out 20 minutes ago, finally came back on, but who knows what they're doing to the lines today. And so if I am knocked off the air, I will just continue this recording and compose this video, and then I'll just attach it to Canvas in the event that that does happen. Okay. All right. First of all, let's work with what quickly was something called simple interest. And as the name suggests, it's simple. It's simple to compute. Simple interest is money earned or computed only on something called the principal. It's PAL, not PLE. The principal is the initial amount of money that is either like invested, if you invest the money and want money to earn money for you, or borrowed, if you borrow money from a bank, some sort of a loan. Okay. All right. And this is the simple interest formula. It is used every day around the globe to compute interest. I stands for interest, and interest is money. P stands for, represents the principal. This is the initial amount of money either involved in investing or borrowing.
The form of the term principal you're using is the principal, like for school principal. That one ends in PLE, the one you're using.
Well, the principal that I am using here is PAL. Principal represents the initial amount of money either borrowed or invested. Okay, that's how they spell this word in our textbook, PAL. All right.
Oh.
Yeah, that's how it's spelled in our textbook. Okay. Section 7.4. All right. R is the interest rate. Now, this is very important. The interest rate initially comes at us in the form of a percent. But ladies and gentlemen, before we incorporate it into this formula, the simple interest formula, we need to turn it into a decimal. And how do you turn a percent into a decimal? Here's an example. If you have like 5.1%, you move the decimal point 2 places to the left and drop the percent symbol. And that's how it will go into the formula, is 0.051. T is something we can never get back. It's called time. And time must always be in years for this formula. So if they say that, you invest money for like 60 months, you cannot put 60 in for time T into the formula. You must convert 60 months into years. And so you would multiply 60 months by this conversion factor. 1 year is to 12 months, which inevitably will have you dividing 60 by 12 and giving you 5 years. You would put 5 in for time if it was 60 months. All right. If the time was like in days, maybe 120 days, you do not put 120 in for time. You got to convert 120 days into a fraction of a year by multiplying it by this conversion factor. 1 year is to 365 days. So in essence, you'll be dividing 120 by 365. And 120 divided by 365 is going to be like about 0.328 of a year. Well, 300 thousandths of a year. Okay.
Please slide your paper up so I can't see.
So that's what you'd put in for time. Okay, so just make sure that however time comes at you, it better be in years when you put it into the formula. Got to be years. All right. So the future value in your account, the future amount, A, or sometimes I like to call it the future value, FV for future value, is going to be equal to the initial principal that you invest plus the interest earned, which is principal times rate times time. All right, here's an example. Suppose we invest, let's say $5,000 for 3 years at 8% simple interest. Find the future value of the account. So in other words, if I go away for 3 years and come back, how much is going to be sitting in my account? We're going to use our simple interest formula to find out. Okay, so therefore, the future amount in our account or the future value, these are going to be used interchangeably, is equal to the initial principal, which is $5,000, plus the interest earned. And the interest earned is going to be $5,000 times the interest rate, which is 8% as a decimal is 0.08, times the time in years, which is 3 years. So if you get on your calculator, you take 5,000 times 0.08 times 3, you will discover that it's $1,200. So you will have earned $1,200 of interest just by letting your money sit in that account and just accrue simple interest over 3 years. Okay. So the future value of this account will be $6,200. That's what will be sitting in your account 3 years from now, provided that you do not deposit or withdraw any money from this account over the 3-year period, and the terms of this account remain fixed throughout 3 years. Those are the assumptions. Any questions about how we computed simple interest? Notice it was computed just by a one-time multiplication of our principal times the rate times the time. That's an example of a simple interest problem. Next, we are going to tackle what is called compound interest. Compound interest is similar to simple interest, but there is a significant difference, and we're going to find out what that is. Okay, so compound interest.
Why when I do that problem, I don't get the same number? Did you just do 5,000 plus 5,000 times the 8% times the 3?
Well, you need to multiply before you add. So you got to do 5,000 times 0.08 times 3. That'll give you 1,200. Then you add it to 5,000. It'll be 6,200. So you don't add 5,000 and 5,000 together first. Order of operations say you multiply before you add. And it should give you $6,200.
Yes, I got that. How did you get the 1,200?
That's 5,000 times 0.08 times 3. That's the
Okay.
interest that we earn. This is the amount of interest we earn, $1,200. All right. Ready for compound interest? So what is compound interest? It's money earned or computed based on the principal and interest already earned or computed. So compound interest is based upon not just the principal, like simple interest is, but it's also based on the amount of interest that has already been earned on that principal. And so compound interest is much more difficult to compute. It requires, if you had a 3-year period, you were investing your money, it would and your interest is compounded to say annually once per year. It would require 3 different iterations, and each time you'd have to update your balance going into each of the years. And each updated balance would carry with it more and more interest. And so the balance grows, and if the balance or the principal grows, then the interest earned grows, which causes the principal to grow even more, which causes the interest to grow even more, et cetera, et cetera, et cetera. This positive feedback method causes compound interest to grow a lot faster than simple interest. Okay. And ladies and gentlemen, here is the compound, the future value compound interest formula. Just like we had a formula for the future value for simple interest, we have a formula for the future value for compound interest. And here it is. The future amount in an account, or the future value of an account, is equal to the initial principal times 1 plus R divided by N, all raised to the N times T power. This is called the future value compound interest formula. FV is the future value of the account, and that is money. P is the principal, which is money, initial amount of money that you either deposit or borrow. R is the interest rate. And of course, it must go in as a decimal. T is time, and that must go in as years. But what's N? The lowercase n here. N is equal to the number of times interest is computed per year or per annum. Typical values for N would be, if N is equal to 1, that means the interest is computed annually. 1 time per year. If N is equal to 2, that means the interest is computed semi-annually. If N is equal to 4, that means the interest is computed quarterly, 4 times per year, usually at the end of each 3rd month period. If N is equal to 12, the interest is computed monthly, 12 times per year. If the interest is computed weekly, then N would be equal to 52. 52 times per year, 52 weeks in a year. If the interest is computed daily, then N would be equal to 365. So these are typical values for N that are used in this future value compound interest formula. All right, let's see if we can put this formula to use. In fact, I will use this formula to work this problem out. $5,000 invested for 3 years at 8%, not simple interest anymore. It's going to be compound interest. So we'll see which one of these accounts pays us more money. Okay, so that's our compound interest formula. That's one you want to have handy. Any of these formulas I put in the box are very important. All right, here's an example. Suppose we invest $5,000 in an account that pays 8% compound interest annually. Find the future value of this account. Notice the interest now is not simple interest, it's compound interest. So we cannot just use our simple interest formula anymore. It will not work. All right, so to the party or the situation, we have to bring in our future value compound interest formula, which is right here. All right, so what is our principal? What's the initial amount of money we're investing? $5,000. What's the interest rate? 8% is a decimal, 0.08. What's time, T, in years? After 3 years. Okay, so time T will be 3. What is N? If the interest is computed or compounded annually, that means once per year. So N would be equal to 1. All right, ladies and gentlemen, let's plug things in or substitute things into the formula here and see if we can make it go on our calculator. So we got 5,000, that's your principal, times, this is times, understood, open parenthesis, 1 plus your interest rate, which is 0.08, divided by N, which is 1, all raised to the 1 times 3 power. Now, this is really equivalent to 5,000 times 1 plus 0.08 raised to the 3rd power. All right, so how would we dial this up on our calculator here? Well, the keystrokes you're going to use on the TI-30XS is you're going to type in the 5,000 right here times open parenthesis 1 plus 0.08 closed parenthesis raised to the, hit your power button, raised to the 3rd power, enter, and you will have your answer. And what do we get? How much money will be in this account 3 years from now if it is invested at this compound interest?
$6,298.56.
That's right. So we will have, at the end of the day, we'll have $6,298.56. Okay. Now, that formula has saved us a ton of work. And I'm going to show you how much work it has saved us. This is something you do not have to write down, but I'm just going to show you. This is how compound interest works. Year number 1, we bring a balance of $5,000 to the table, plus the interest earned during the first year, which will give us a new updated balance of $5,400 at the end of year 1. Year number 2, we carry the new updated balance into the 2nd year. Okay, into the 2nd year, and it is going to earn during the 2nd year some more interest. And at the end of the second year, the new balance will be $5,832, I believe. This new balance is going to be carried over into year 3. And in year 3, our $5,832 is going to earn another year's worth of interest. Only the principal is bigger now. It's $5,832. It's no longer $5,000. And at the end of the third year, you'll have your $62.98.56. So this is just a quick snapshot as to how compound interest works. You see, the principal keeps building at the end of each year. And a larger principal earns more interest. And more interest causes your principal to grow even bigger, which earns even more interest. So it's this snowballing effect, if you will. That's the nature of compound interest. It grows a lot faster than simple interest. Okay. In fact, I can show you the difference with the graph between simple and compound interest. Horizontal axis is time, the vertical axis is the future value. Simple interest grows at a linear rate. At a linear rate. This is the growth of simple interest. But here's how compound interest grows. Compound interest grows at an exponential rate. Its growth is like this. So in the initial years or time of investment, simple interest might grow faster than compound interest. But eventually, compound interest is going to win the war big time. It's going to really take off fast, where simple interest is a slow climb. So it would be in your best interest to, no pun intended, to invest your money in a compound interest account as opposed to a simple interest account, because compound interest grows faster. I like to think of compound interest as being kind of like something you experienced maybe in the wintertime. You got a high hill here, you build a little snowball up here. You roll the snowball forward a little bit, the snowball picks up more snow. And because it picks up more snow, it becomes bigger and heavier, which causes the snowball to dig even deeper than the snow, which causes it to pick up even more snow, which causes it to grow even faster. Excuse me. Which causes the snowball to become even heavier, which causes it to dig even deeper into the snow, picking up even more snow, causing it to grow even faster. And by the time you get down here, ladies and gentlemen, you have a boulder. That's how compound interest grows. Initially, the interest is computed on the initial principal, but the interest that is added onto the principal causes the principal to become bigger, which causes it to earn even more interest, which causes the principal to become even bigger, which causes it to earn even more interest. And this snowballing effect, or this positive feedback method, continues on and on and on. So compound interest grows very quickly, as opposed to simple interest. It grows at an exponential rate, not a linear rate. All right, maybe we can try another one here. Okay, any questions how we computed this one here? Compounded annually. Let's try another one here. All right, another example. Suppose you want to find the future value and interest earned on $11,000 compounded daily at 5%. Let's make it more interesting, at 5.3% for 6 years. Tell you what, let's make this even more interesting still. For how about 120 months? There we go. All right, so we're going to use our future value compound interest formula here. Principal times 1 plus R over N, all raised to the N times T power. All right, what's my principal? What is my principal here? How much am I investing initially?
11,000.
$11,000 your principal. What's the interest rate? R is a decimal.
0.053.
0.053 is the interest rate. The time is what? Not 120. It's not 120 years. It's 120 months. We got to convert this into years. So it's going to be 120 months times 1 year per 12 months, which causes you to divide 120 by what? 12, which
Should
gives
be 10.
10 years. Time is 10, not 120. All right, what's N? If the interest is compounded daily or computed daily.
And over 365.
Well, compounded daily, no, the interest is compounded daily. So that means that N is going to be what? How many times per year would that be then if it's daily, computed daily?
365.
It would just be 365. That's it. Okay. All right, here we go. Let's plug the numbers in where they belong. So we got $11,000 times quantity 1 plus the interest rate is 0.053 divided by N, which is 365. All raised to the, and I'm going to put this inside parentheses, this exponent, all raised to the 365 times 10 power. How do we enter then this monster in on our calculator on one line? Well, here's how we do it. We start off with 11,000 times, it's understood there's multiplication between 11,000, the open parenthesis. Now open parenthesis, 1 plus 0.053 divided by fraction bar means division. 365 closed parenthesis raised to the, get your power button, open parenthesis 365 times 10 closed parenthesis. Right arrow key to bring your cursor back down to the main level. Enter. You will have your answer staring at you. That's how you type it in literally keystroke per keystroke on the TI-30XS.
How did you get N to equal 365?
Because the interest is compounded daily. That means 365 times per year, correct? Remember, N is the number of times interest is computed per year. So if it's compounded daily, N is 365. If it's compounded monthly, N is equal to 12. If it's compounded weekly, N is equal to 52. Compounded annually, N is 1. Compounded semi-annually, N is 2. Compounded quarterly, N is 4. Okay. All right, ladies and gentlemen, get on your calculator, dial this up. Tell me what the future value of this account's going to be.
Would it be $1,868.75?
Well, if it's only $1,000, that means we lost something like almost $10,000 was lost. Do you agree?
Oh, that's
Oh my
like,
goodness, we put 11 grand into the start. It better be more than 11 grand, because I'm going to a different bank. No,
I
what's
did it wrong.
yeah, make sure you dial it in exactly how I told you these keystrokes. Okay, that types this whole thing in on one line. Anybody? What do we get? Let me know if anybody gets it. Well, I worked it out. And after working it out, well, Hold on a second.
$18,687.53, 54 cents.
Okay. Yeah, I'm getting $18,687.54. And is that what you got?
Yes.
All right. That's the amount of money that'll be in your account 3 years, excuse me, not 3 years from now, 10 years from now, correct? So how much interest was earned? Interest earned over this 10-year period. Well, that's going to be your future value minus your initial principal. So that's going to be this $18,687.54 minus $11,000 that you initially plunked into the account. And that's gonna give you,
$7,687.54.
yeah, it's going to give you a hefty amount of change that was earned. Do you agree? $7,687.54 was earned just by letting your money sit in that account for 10 years, ladies and gentlemen. Investing money does require discipline, though. I mean, it assumes that we don't dip into this account over 10 years. We don't take any money out. So we got to just put the money in there and go away and forget about it for 10 years. But if we do so, our money will have grown to $18,687.54. All right. So I've shown you two problems that involve the future value compound interest formula computation, correct? All right, we're going to look at a different question now. Here's a different question. What if it says, suppose we want to save $5,000 before buying our first car. We have $3,000 right now to invest at 3% interest, compounded monthly. Here's the question. How long will it take to get our $5,000? That's the question. How long is it going to take? Now they're asking us for time. They're not asking us for the future value of an account. And because of that, ladies and gentlemen, don't get me wrong, we're still going to use our future value compound interest formula like we have in the past examples. But now, notice, what do we know? We know the principal is what? $3,000. Do you agree? That's the initial amount we plunked in the account today. The interest rate R is 0.03. And since our interest is compounded monthly, N would be 12 times per year. Time T, we don't know. We're trying to find the time. And we know the future value must be $5,000. How do we solve for time T? How do you take this nasty equation and solve it for the variable T here, time? Well, I already did that behind the scenes. So you don't have to worry about all the algebra you have to go through to do this, ladies and gentlemen. This is the formula you need to know, though, for this type of question. The amount of time T is going to be equal to a brand new function we're going to show you on our calculator called the log function. Log of the future value divided by the principal divided by n times log of 1 plus r over n. A logarithm is an exponent. Okay. Now, you could kill a whole session talking about logarithms, and we don't have that time. So just to give you a quick taste of what a logarithm is, this is basically what a logarithm is. A logarithm is an exponent. So if I take log, now if you see log, it's understood to be your base 10 logarithm. So this is our common log or base 10 log here. If you take log base 10 of like 100, it would give you an exponent. Stop and think, what power would you have to raise base 10 to give you 100? 10 to what power gives you 100? 10 raised to what power would give you 100? 2. So if you take log of 100 on your calculator, you should get 2. What would be log base 10 of 1,000? What power do you have to raise base 10 to give you 1,000?
3.
3. So if you take log of 1,000 on your calculator, it better report 3. That's basically what a logarithm is. It's an exponent. When you take the log of a number, it's equal to an exponent. This is the exponent. This is the exponent. All right, where does this log function hang out on our calculator? Well, let's go find out on the TI-30XS.
Right underneath the second function button.
Yeah, it's right underneath, ladies and gentlemen, the second button, up in the upper left corner of your keyboard, you have a button that says second on it. And by hitting the second button and following it with some other button, it causes you or enables you to activate a function that's above a key on your calculator. Okay. So whenever my smart view ever comes up here, I will hopefully be able to show you where the log function is. Right below the green second key is the log button. That's your base 10 or your common log function button. Log. Watch this. If I take the log of 100, it better give me 2, because 10 raised to the second power is 100. See how that works there? Log of 1,000 better be 3. What if you take the log of 7? It gives you a messy decimal. You'd have to raise base 10 to this power here, this decimal power, to give you 7. So that's the log function, okay, on your calculator. All right, let's get back to our problem here. All right, so ladies and gentlemen, here's what we're going to do. We're going to use this formula here. So the time required for our money to grow from 3 grand to 5 grand is going to be log of the future value is $5,000 divided by the principal is 3,000. And that's all divided by n, which is 12 times log of 1 plus the interest rate, which is 0.03 divided by 12. Now, how do we type this all in on one line? For one thing, I would strongly recommend you enclose your entire denominator within parentheses. Now, here you go. On your calculator, you hit your log button to start out. Log. Now, when you hit your log button, this function presents you with an uncontrollable open parenthesis. So that will be this open parenthesis. So hit your log button. We have log, open parenthesis, 5,000 divided by 3,000. Closed parenthesis. Fraction bar means division, this fraction bar. Open parenthesis. 12 times, understood it's times, log. Go hit your log button again. It automatically gives you an open parenthesis. 1 plus 0.03 divided by 12, closed parenthesis, enter. You will be looking at your answer. Okay, there you go. That's how you type that in, literally. And how much time is it going to take? Round off to the nearest year, please. About
18
what?
years,
How many years?
18
Now,
or 17.
was this, yeah, the nearest year I think was 17. It's not quite as close to 18. So about 17 years. Wow. Ladies and gentlemen, it's going to take 17 years for you to what? Accrue $2,000 worth of interest. Do you agree? You could probably find that in bottles and cans along the road faster, correct?
For sure.
So why is it taking so darn long for our money to grow? I'll tell you why. The interest rate is so confounded low. Do you agree? 3%. That's a very low interest rate. Be better if you had an interest rate, maybe what, 10, 12%, something like that, correct? Your money will grow a lot faster. All right, that makes sense how we found the time, though, using that formula here for a problem like this, a question like this. So that's an important formula. Have that one handy. You never know when you're going to run into a question like we just got done doing there, okay? All right, the next problem I'm going to show you is still using the compound interest formula. But ladies and gentlemen, this is not going to be a future value problem. This is going to be called a present value problem, a present value problem. So it's called the present value compound interest problem. And here's how it is worded. A recent college grad plans on saving money to attend graduate school. In 6 years. She wants to have $22,000 saved at that point to help pay tuition. How much would she have to invest today? At 5 1/4% compounded quarterly interest to reach this goal. Okay. This is our future value compound interest formula we've been using over and over again. What do we know in this formula? What do they give us in this problem? Do we know the principal? The initial amount we must invest today? No, that's what they're asking us for. How much must we invest today? We don't know that. Do we know the future value of this account? Yes, we know that we need to have $22,000 in the future. Do we know the interest rate? 5 1/4% as a decimal is going to be 0.0525. 5.25% as a decimal is this, 5 1/4%. Do we know N? Well, the interest is compounded quarterly. That means 4 times per year. Do we know time? 6 years. Ladies and gentlemen, they call this a present value problem, not a future value problem. Because in the past, we knew what we were investing today, and we wanted to know what the future value was going to be. The tables have turned now. Now we know the future value, but we don't know how much we must invest today. That's why we call this a present value problem. Present value. We have to solve this formula for P, the initial principal we must invest today, to ensure that in 6 years, we'll have $22,000 waiting for us. How do we solve this formula for P? Well, I've already done that for us, so you don't have to worry about that. But you do have to have this formula handy. So here it is, ladies and gentlemen. The present value P is going to be equal to the future value divided by 1 plus R over N, all raised to the NT power. There you go. This is called your present value compound interest formula. Very important formula. Present value compound interest formula. That's another one to put in your toolbox. All right, let's see how it works for this situation here. My present value is P. I don't know what it is. My future value is $22,000 divided by 1 plus the interest rate, which is 0.0525 divided by N, which is 4, all raised to the N times PT power, 4 times 6 power. We got to get on our calculator and dial this up. So how do we present this to the computer? We start off by typing in 22,000. This fraction bar means one operation.
Divide.
Divided by open parenthesis. If you don't include these parentheses, you're not going to get the correct answer. You're going to get a logical error. Parentheses force precedence, so they're very important. 1 plus 0.0525. This fraction bar means divided by 4, closed parenthesis, raised to the power button, open parenthesis here, 4 times 6, closed parenthesis, closed parenthesis. Hit your right arrow key to bring your cursor back down to level. Enter. You will be looking at your answer. Go ahead and dial it up and tell me, ladies and gentlemen, what she must invest today to ensure that in 6 years, she will have $22,000 to pay for her graduate education.
$16,088.29.
Okay, $16,088 and what?
29 cents.
29 cents. Anybody else get that?
I didn't get it.
That sounds
I
about right.
did.
Remember that number. I remember this number. So this is,
I got it.
this is correct. Okay, there you go. That's what she must invest what? Today. Do you agree? To ensure that in 6 years, she will have that $22,000 waiting for her. This is called a present value compound interest problem. Present value. So the formula you're going to have to use will depend upon what the question is. Okay, so obviously the challenge is going to be knowing, after reading the problem, what formula to use, and then obviously how to use it, how to type it into the calculator. All righty, I'm giving you all these formulas for these different cases here, these different types of problems. All right, ladies and gentlemen, we're done with that problem. Now we're going to look at something different. We're going to look at what's called an annuity. An annuity. Have any of you ever heard of the word annuity in the business world, the finance world? Annuity? What's an annuity? An annuity. Well, when I first seen that word, I blew it big time. I called it annuity, and somebody laughed about that because I totally botched its pronunciation. It's annuity. That's how you pronounce this word, annuity. What is an annuity? An annuity is a savings investment where equal payments, this is the key, equal payments. All annuities are characterized by a stream of equal payments that are made into a compound interest account. To achieve a future value. And so right off the bat, I'm going to give you yet another formula. It's called the future value annuity formula. You don't have to know where it comes from. You just have to know what it is and how to use it. Here it is. The future value or the future amount in an account is going to be equal to uppercase R times open parenthesis, 1 plus R over N raised to the NT power. We've seen this before. This was part of our compound interest formula, wasn't it? Minus 1 closed parenthesis, all divided by R over N. And I would enclose this inside parentheses to stay off any logical error. All of these variables look familiar except one. What is it? What's the new coming letter into
The
this?
uppercase R.
Uppercase R. What is uppercase R? Les amis, uppercase R is equal to the regular periodic payments. The regular periodic payments made into the annuity. Now, an annuity could also be thought of as taking regular payments out of, an account. For instance, what comes to mind would be like a retirement. When you retire, don't you take out equal installments or equal payments on a monthly basis to live out your retirement? That's kind of like an annuity, kind of like in reverse. All right. Normally, annuities have us paying into, an account so as to realize some future value. But annuities can also be taking equal installments out of. Annuities are all around us in our everyday lives. For instance, if you pay a monthly mortgage payment, the same amount each month, that's kind of like an annuity in a way. It's equal payments over a periodic amount of time. All right, so this is a very important formula. And what type of problem will it enable us to solve? Well, I have one waiting for us here, and here it is. So we're going to try to apply this formula to a problem like this. Here's a classic example. Suppose that we open up an annuity with semi-annual payments of $800 at 5% compounded semi-annually. So, ladies and gentlemen, when you do an annuity problem, the frequency of your payments is always going to be equal to the frequency of compounding, okay? For 4 years. So here's a classic problem here that involves an annuity. A, I want us to find the future value of the account. B, find the interest earned. How much interest did we earn? All right, so here's a classic problem you'll run into maybe on Alex, okay? Now, how do we know it's an annuity problem? What word kind of clues us into that situation? I'll give you a hint. How about the word annuity? Do you agree? Pretty obvious. It's an annuity problem. And so, ladies and gentlemen, we're going to use this formula here. So help me out here. What's my interest rate R for this problem? What's lowercase r? Lowercase r.
5%.
5%, 0.05. What's N? How many times is the interest going to be computed or compounded per year? Semi-annually means how many times per year?
2.
2 times per year. T is time. How many years we talking about totally here? 4 years.
4 years.
Now, what's uppercase R? What's going to be our regular periodic payment that goes into this account? This annuity, excuse me.
800.
$800, and that will be what? Paid how many times per year?
4.
Semi-annual means twice per year. Twice per year, we're gonna what? Pay into this annuity $800. So probably at the end of each 6-month period, correct? We will pay in $800 into this annuity out of our pocket. That's the periodic payment. Okay, all we gotta do is plug in everything we know into this formula, ladies and gentlemen, get on our calculator and dial it up. We'll have our future value at the end of 4 years. So that's all that remains now is substituting the numbers into where they belong and then dialing it into your calculator correctly. So therefore, the future value is going to be equal to the periodic payment, which is $800 times open parenthesis 1 plus interest rate 0.05 divided by n, which is 2, closed parenthesis raised to the n times t power, raised to the 2 times 4 power, minus 1, closed parenthesis, all divided by r over n, 0.03 divided by 2. Get on your calculator, and how would you dial that up on your machine? You'd say 800, start up here, times open parenthesis, 1 plus 0.05 divided by 2, closed parenthesis, raised to the open parenthesis. I'm up here now. 2 times 4, closed parenthesis. Bring your cursor back down to level, right arrow key, minus or subtract 1, closed parenthesis, divided by, this fraction bar means divided by. Denominator now, I'm down here, open parenthesis, 0.03 divided by 2, closed what? Parenthesis. That should do it, okay? So it's a complicated calculation.
Where did you get 0.3 from?
0.03? Well, that was,
There's a form that
wait a minute. Should that be 0.05?
Yeah.
5%, shouldn't it? Son of a gun. Yeah, this should be 0.05. Same as this up here. Yeah, this should be 0.05. My bad. There you go. This is okay. All right, go ahead. Dial it up and tell me how much money, ladies and gentlemen, is going to be in our account 4 years from now. In this annuity.
38,988 and 89 cents.
Is that right? 38,000? I like your bank. I want to come to your bank. Get my bank here. $38,000?
I got 6,988.
That's not quite that much there. Careful, double check how you maybe type that in. I got $6,988.89. Will be waiting for us 4 years from now.
Okay.
That's what that annuity will be presenting to us in 4 years. So, ladies and gentlemen, not only are we making equal installment payments into this annuity, but as we do so, that money is what? Accruing more and more interest because the principal keeps growing through time. Do you agree? And so the interest keeps growing through time, causes the principal to grow through time, et cetera, et cetera, et cetera. It's this positive feedback method that causes our money to keep growing and growing and growing. All right. So that's a classic annuity problem, future value annuity problem there.
Okay, I forgot to take away one.
Yeah, there you go. That's part of the formula. That's important. You know, with practice, as always, ladies and gentlemen, the more practice you do, the more comfortable you're going to get at, you know, this whole process. You know, which formula to use for which problem, how to type it in on your calculator, et cetera, et cetera. That's only going to come through practice. So that's why it's critical to try to not only do Alex, but I would recommend you also go into your textbook and try to do some odd problems at the end of each section. Make sure you check your answers in the back of your book too. I would recommend that strongly that you do that. Also, maybe look over all the examples in the sections too. Your author does a nice job laying the steps out. Okay, very important. All right, I have one more problem before we can maybe go to our textbook and have some fun. Here's the question. Suppose you always dreamed of opening your own tattoo parlor. Well, if you're not into dreaming that, ladies, I mean, you can fill in a blank with what other dream you might be interested in and decide it's time to do something about it. A financial planner estimates that you would need $35,000 initial investment to start up your business. And you plan to save that amount over the course of 5 years by investing in an annuity that pays 7.5% compounded weekly interest. How much would you need to invest each week? In other words, how much would I have to pay into this annuity, okay, each week for 5 years to ensure that I will have $35,000 waiting for me in the future? This is another classic problem involving an annuity. But now they don't want us to find the future value of the annuity. We know the future value is $35,000. They want us to find out how much money we have to put into the annuity on a periodic basis. And so, ladies and gentlemen, we have to find what in our formula? What are they asking us to find here? We know the future value now. They want us to find uppercase R. Do you agree? What's going to be our periodic weekly payment into the annuity? So we have to solve this formula for uppercase R. Well, I've already taken the liberty of doing that, so you don't have to go through all the algebra, all right? So this is another important formula you need to have, though, okay, in order to determine what your periodic payments have to be into an annuity to realize some future value. And this is what the formula would be if you solved it for uppercase R. And there you go. So this is a very important formula that can tell us what our periodic payment has to be into an annuity to realize a future value T years later. Okay. That's a very important formula that's going to help us solve this word problem. All right, so yeah, make sure you have this one handy amongst all the other formulas we've built throughout the section here. So what is my lowercase r? My interest rate is what? 7.5% as a decimal is 0.075. 0.075. N is the number of times per year the interest is compounded. It's compounded weekly. So how many weeks in a year? There's 52 weeks in a year. N will be 52. T, time, is the number of years, which is going to be what? 5 years. What else? Let's see. I think we got everything. The future value is going to be what? What's our future value? We want our annuity to have $35,000 in it 5 years from now. That's the future value. Okay, here we go. We got to just plug things into our formula, get on our calculator, and dial it up, and we'll have it. I recommend enclosing this entire numerator inside parentheses. So we got 35,000 times open parenthesis 0.075 divided by, this is divided by n, which is 52, close parenthesis, divided by open parenthesis, 1 plus r over n, which is 0.075 over 52, raised to the nt power, which is the 52 times 5 power, and minus the 1. Don't forget that minus 1 there. Okay. See if you can get on your calculator and dial this up. Ladies and gentlemen, how would you do that? Well, on the calculator, you would start by typing in 35,000, open parenthesis here first. Open parenthesis, 35,000 times, open parenthesis, 0.075 divided by 52, close parenthesis, divided by, fraction bar means division, divided by, open parenthesis, 1 plus 0.075 divided by 52, close parenthesis, raised to the open parenthesis, 52 times 5, closed parenthesis, bring cursor back down to level by hitting right arrow key, minus 1, subtract 1, closed parenthesis. Enter, you would have answer. Okay. All right, there you go. That's how you literally type it in. Okay.
1104.
What would be our weekly payment?
1104.
$111.04. So
Yeah.
you would have to pay into this annuity $111.04 per every what week for how many years?
5.
5 years. And if you do that religiously, okay, and exercise discipline and don't waver from this savings plan, guaranteed in 5 years you will have waiting for you $35,000, guaranteed. Now the question is, how much interest did this annuity earn for us over the course of 5 years? Well, we're going to find that out. Look at, if I just made $111.04 of payments per week, times how many weeks in a year? 52 weeks for 1 year, right? For how many years? 5 years. What's going to happen here? Weeks cross cancel out, years cross cancel out. We're left with what money? Get on your calculator. What's 111.04 times 52 weeks per year times 5 years? How much money came out of our pocket that went into this annuity over the 5-year period? You're about to find out. 111.04 times 52 times 5. We laid out $28,870.40. And our future value of this annuity will have grown to what? $35,000. So what interest was earned from the annuity? Well, you just take the $35,000 and subtract off the $28,870.40. And what do you get? This annuity will have earned for us $6,129.60. That's how much this annuity will have earned for us over the 5-year period.
With doing this, you're just trying to find the interest earned.
What's that?
By doing this problem, you're
Yeah.
just trying to find the interest.
That's right. That's right. Trying to find how much interest we earned. Because look, if we just threw this money in, let's say, put it in a jar and buried it in our backyard, do you agree we would have only what, $28,870.40 after 5 years? Do you agree? If we just did this, $111.04 per week for 52 weeks per year for 5 years. This is the amount we would have in our cookie jar in our backyard. But by investing in this annuity, ladies and gentlemen, that pays compound interest, we will have earned on top of that $6,129.60 of pure interest, which would have built our account up to $35,000. So, hey, if you can invest in an annuity, your money's going to earn money for you. If you just put it in a cookie jar in your backyard, you're not going to earn any interest. Why not make your money earn interest for you? You know, if I won the lotto, ladies, I'm going to say I won $10 million after taxes. I would invest about $2 million in a savings account, or maybe a checking account, or a certificate of deposit, which is low risk but low yield. You see, if you play the stock market, there is the potential for high yield, but there's also high risk involved. There's other savings investments or vehicles, such as mutual funds or certificates of deposits, which are lower yield but lower risk. So you have to make a decision as to how much risk you're willing to take in your life. But the bottom line is, why not make your money work for you? Okay. Even when you're sleeping, your money could be earning money for you if you just invest it wisely. But if I won $10 million, ladies and gentlemen, at a lotto, let's say, I would invest $2 million, plunk it into some sort of savings vehicle, and you know what? I could probably live comfortably off of the interest alone. The interest alone could net me maybe $100,000 a year, just interest, pure interest. And I could live on that, never touch one penny of the principal that I put into the account. Never touch it. I could live on the interest alone. Isn't that amazing? So if you do win the lotto, maybe consider investing some of your money, huh? So you don't go broke. I mean, don't just go, have a big old party and blow it all in one night, right? Might want to invest it. And I help your money, make your money earn money for you. Okay, ladies and gentlemen, let's go to our textbook and see if we can maybe have some fun. We got some time left here. I wanted to maybe demonstrate a couple more problems, or maybe have you work out a couple problems, since there hasn't been any classwork yet. These problems will be coming out of section 7.4, compound interest. And like I said, feel free. The book's right here staring at you. Feel free to look down through the examples, study the examples, and then feel free to do as many of these odd problems down here as you can possibly, fit into your busy schedule. It's only going to help your cause in this section. Okay. See, we worked with nasty formulas like this. Do you agree? Recognize the formula there? That's the future value of an annuity formula, is it not? I showed you that formula. All right. Let's go down and see if we can play around with some of these interesting problems here. Okay, number 34, ladies and gentlemen. A recent, no, we already did that problem there. Okay, let's not do that problem. 33. In fact, you can do 33 maybe for classwork number 1. The elders hope to accumulate $12,000 for a sunroom over the next 6 years. How much would they need to invest today, right now, at 3.9% compounded quarterly to reach their goal? I have a question for you, ladies and gentlemen. Is this an annuity problem? Is this an
No.
annuity problem? Is it an annuity? Does it say anything about periodic payments, or does it say the word annuity anywhere? Doesn't look like it. You know what this is? This is a what? Is this a future value or a present value compound interest problem? Which one is it? Future value or present value compound interest problem? It's one of those. Which one is it? Is it a future value or a present value compound interest problem?
Future?
No, not future value, because we know the future value has got to be $12,000. They want to know how much money we have to invest, what, today, right now. This is a present value compound interest problem. Do you have that formula? Look through your notes. Where is the present value compound interest formula? You got it somewhere? The present value compound interest formula. Where was that formula? Where is that formula? I know we got it somewhere here.
Yeah, it's I
Got to
think
be the
it's,
present value formula, not the future value formula.
yeah, present value compound.
Okay,
interest.
could you read off that formula for us?
P equals future value over, in parentheses, 1 plus R over N, parentheses, to the N times T power.
Okay. And there you go. There you go. So this is the formula we got to bring to the party here. This is the formula there, ladies and gentlemen. These extra parentheses are not even needed here, not for this. So future value divided by 1 plus R over N to the NT power. This will give you the amount of money we have to invest today to ensure that our money will grow through compound interest to some future value. So that's the formula you're going to need to use for number 33. Go ahead and do number 33. This will be classwork number 1, 33. All right, so this is what we know on the word problem number 33. We know the future value, the time, the interest rate, and the number of times the interest is compounded or computed per year. We plug the numbers into our present value compound interest formula, and then we just have to get on our calculator and dial this up. So let's see. What must we invest today to ensure that in 6 years we'll have $12,000 waiting for us? Well, we're going to find out.
$9,507.11.
All right. Okay, that sounds pretty good. So we're gonna have to go down to the bank here and invest one lump sum of money today, which is $9,507.11. And if we do that and walk away for 6 years and come back 6 years from now, we will have sitting in our account waiting for us $12,000. That's your answer. Any questions how we did number 33 using the appropriate formula there? So yeah, it's really going to come down to our ability to recognize what formula we're going to need to use to address the situation and answer the question. And that's why I boxed in all those formulas. You know what I would recommend you do, ladies and gentlemen, is put all those formulas on one sheet of paper and make sure you label what the formula pertains to. Okay, like you'll put this formula on your piece of paper and you'll call it the what? This is called the present value compound interest formula, present value, meaning that they want you to find the present value, not the future value. Okay, if you put them all on one card, one piece of paper, it'll speed up your ability to sift through the ones you don't need to get to the one you do need to use. All right. All right, any other questions on that problem there? 33. All right, now I want to turn our attention to problem 52 here. This will be classwork number 2. It says a 25-year-old decides that their goal is to retire at age 50. Lucky them. With at least $2 million in savings. The company investment annuity offers 7.4% annual returns, compounded monthly. What amount will they need to invest each month? So, ladies and gentlemen, I got a question for you. Is this a simple present value compound interest problem? Or might it be like a present value annuity? It's one of those two. Which one is it?
What was the question number for class,
For what? Which one? Number one?
classwork number 1?
Number 33. That was 33, was classwork number 1. Okay. And we got $9,507.11 for number 33. All right. Okay. Number 52, classwork number 2. What kind of a problem is this? Is this a present value compound interest problem or a present value annuity problem?
Annuity.
How do you know that?
Does it say the investment annuity offers?
Yeah, there you go. You got all these hints here, ladies and gentlemen. It says investment annuity offers. And look at this. It says what amount will they need to invest each what? Each month into the annuity. That's an equal size stream of payments going into this annuity. That's why we call this an annuity. Okay. So what formula are you going to need to use? Uh-oh. We got a whole bunch of formulas now. Which one are we going to have to use now? Let's see. What is it? Present value annuity.
Periodic payment.
Yes. Could you read that formula off to us? Remember I solved it for R? That's the one we need.
R equals parenthesis future value parenthesis R over N parenthesis divided by 2 parentheses 1 plus R over N parenthesis to NT minus 1 parenthesis.
You got it. That's the formula we need to use. This is called the present value annuity formula. We write that down. Present value annuity formula. Because they want to know what amount of money do we have to pay into it today and in equal installments in the future to ensure that we get a future value from this annuity. Use that formula for number 52. Go ahead. Classwork number 2.
What is there going to be another? Is there going to be another classwork assignment? Because I'm going to have to go in a bit.
No, that's okay. If you don't get it, don't worry about it. Just send me what you got. Okay.
Okay, I'm
You
gonna do
can,
it
you
a
can,
little,
you'll be able to see it on the video, all right?
I'm gonna do it a little bit later.
Okay,
So I have the problem numbers written down
no
on a
problem.
piece of paper and the equations.
Okay, no problem. Go ahead.
Okay. Have a nice day.
I will see you. All right, number 52, classwork 2. I got a question, Lisa. What would time be? How many years we talking?
25.
50.
That's a 25-year-old that wants to start investing today so that when they're 50 years old, 25 years later, they'll have $2 million in their account for retirement. It's 25 years for time. All right. So these are the values that we need to now plug into this in order to find what has to be our periodic payment into this annuity to ensure that we'll be able to retire when we're 50. And this periodic payment is going to go into the annuity every month, 12 times per year.
$2,316.64.
All right. Hold on. I got to catch up to you. Just make sure you, of course, type it in correctly on the calculator. Yeah, time is 25 years. All right. Let me dial it up on the machine and we'll see if we can get what you got there. What did you get now?
Oh, I'm sorry. I got 2,316 and 64 cents.
2, 3, 4, 5, 6. Huh, let me double check. Something's amiss. What the heck? Did anybody else get that or? What's going on here? Yeah, I'm getting something a little different than that.
I got 2,316.
Okay. Son of a gun. Maybe I typed it in wrong. I only got 1950. Let me double check this. Hold on. We'll type it in one more time. 1, 2, 3, 4, 5, 6. What the? You sure I got all my numbers right here. Oh. Oh, I forgot to subtract 1, I believe. Okay, so what did you get? Yeah, you are correct. It is,
2,316.64.
there you go. So we would have to pay this, was it weekly, monthly? What was it again? We'd have to pay that each month. So we would have to pay this each month into this annuity for 25 years. And ladies and gentlemen, in 25 years, we'll have waiting for us in our account $2 million. Wow. Now, granted, that does sound like somewhat of a sizable monthly payment. Don't get me wrong. I mean, that's nothing, to sneeze over. That's not like pocket change for most people, correct? So I mean, would you be in a position to do this? Maybe if you lowered your sights and said, oh, well, okay, maybe I'll just settle for $1 million, then your monthly payment would be lower. Or if you extended this payment over more time though, but then it would take you longer to retire. So I don't know, there's different ways of looking at this. It depends on your personal situation, but that's what we get, correct? If we made this monthly payment for the next 25 years, we would have $2 million in our account, 2 million. So I have a question for you. How much interest will have been earned? I am dying to know. Interest earned. Look, if we just made this payment every month for 25 years, how much will we have invested in this out of our pocket? That would be 2316.64 times 12 times 25. Dial it up on your calculator. This is the amount of money that we would have thrown into the account out of our pocket over the 25-year period. Times 12 times 25. Wow. Okay. So, ladies and gentlemen, we will have thrown into this account $694,992. But how much interest did we earn? Wow. We earned a lot of interest because holy baloney.
4,000.
Yeah, we learned tons. We earned tons of interest.
192, yeah.
We earned $1,305,008 worth of what? Interest. Do you agree? Look at all the interest we earned over 25 years. $1,305,000 and $305,008 of interest we will have earned over 25 years. Yeah, we laid a lot of money out of our pocket, but look at all the interest we earned though. Might be worth it. What do you think? Huh? I mean, if you're young, but just like planting a tree, the best time to have planted a tree is like what?
18, soon as you get started.
That's right. Same thing in investing, ladies and gentlemen. The sooner you can get started investing when you're young, do it. Because you're only getting older and time you can never get back. Okay. So do it as quickly as you can possibly do it. The best time is now. All right. All right. Or yesterday, as they say. All right. So that's a classic problem, number 52 there. I'm going to back up to number 46 here. Maybe we can try this one for classwork. I just want you to do 46A. Don't worry about B. Titan Thigh, the owner of Work It Out Fitness, wants to buy an annuity that pays 4% interest compounded quarterly for 4 years. If the quarterly payment is $160, what would be the future value of this annuity? Go ahead and do that. We'll call this classwork 3. What formula do we got to bring to the party here? What kind of a problem is this? Is this a future value or present value annuity?
Present value annuity.
No, careful. No, they're telling us the present payments are going to be $160 4 times per year.
Okay, I thought you was asking about the question.
They want us to find, the future value. So this is the future value annuity problem, correct? They want us to find the future value. All right, go ahead and do that. Make sure you use the right formula. And what is that formula? It's the future value annuity formula. And I believe it is future value is equal to what? Wasn't it R times something?
R parentheses 1 plus R over N.
Where is the stupid thing? Hold on a second. I had it right here and I lost it. Here it is. Parenthesis 1 plus R over N raised to the NT power minus 1, all divided by what? R over N, correct? That's the formula you got to bring to the party. That is called, this is called the future value annuity formula. Future value, because we're solving for the future value, annuity formula. That's what you need to do this problem. And in number 52, excuse me, number 46, what do we know? We know R is 4%, which is 0.04. We know N is compounded quarterly, 4 times per year. N is 4. Time T is 4 years. The periodic payment that goes into this annuity is $160. That is made per 4 times per year. Go ahead. For number 46, find the future value of that annuity.
$2,761.26. Is that what that was?
All right, so what'd you get now? 2,000?
$2,761.26.
All right. So that would be the future value of this annuity. $2,761.26, provided we pay $160 into this annuity every 3 months for the next 4 years, we will have $2,761.26. So what would be the interest earned? Well, it's going to be the $2,761.26 minus $160 goes in quarterly, which means 4 times per year, correct? So that's 4 times per year times how many years? 4 years. So 160 times 4 times 4.
201.
Yeah, so it's not a ton of interest because we're not talking about a lot of time here. That's the thing. So obviously, the marvel of investment, ladies and gentlemen, is leaving money in an account for a large number of years. That's where the magic occurs, is through a large number of years. I mean, if you just leave your money in the account for like 2 or 3 years, it's not going to, earn a tremendous amount of money for you. So that's why if you want to invest for like a retirement or maybe for your kids or grandkids' education, try to invest as early as possible. And that way, let time, take care of all the heavy lifting for you. And obviously you want to try to get locked into a good account with good terms, high interest rate, and then maybe a low monthly payment to boot, so you can still live a life. All right, so let's see. All right. So I think we looked at one of each type here. I think we might be good. Yeah. So I think we're good, ladies and gentlemen. I think we looked at one of each type here. Okay. And well, let's see here. Yeah, I think we're good. All right. So today we touched base with compound interest in general, and how it can be used to compute future values, present values, how to compute how much time it would take for money to grow to a certain value. Also, we looked at something called an annuity, present and future value annuities, and we basically amassed a whole bunch of formulas. And like I said, I would strongly recommend that you probably put those formulas on one page and make sure you label each formula so that it gives you a hint as to what it is used for. And then I would strongly recommend that not only do you do problems obviously on Alex, but I would recommend you go into your textbook, maybe do some of the odd problems also in your textbook. You don't have to do them all, but just do a couple out of your textbook odd problems whereby you feel comfortable in knowing what formula to use and how to use it. Make sure you're always checking your answers in the back of your book. And that's why you want to do odd problems in your textbook. I think that will help you do better on Alex when you go to Alex. And so I would recommend always doing, maybe looking at your sections in your textbook, doing some extra odd problems at the end of each section, checking your answers. Then you go to Alex and do the Alex homework. Then you do the Alex quizzes, and then you do the Alex exam in that order. I think you'll have the maximum success. All right. All right, I'll let you go. I'll stay on the line for a couple minutes if you have any questions or concerns. If not, have a great day. And in 2 days, we'll start looking at probability. Okay. Probability on Thursday.
Could you post the 7.4 homework and quiz today?
All right, what's going on?
Could you post the 7.4 homework and quiz today?
Yeah, I'll try to do that, okay?
Thank you.
All right. Yep.